Section 9.3, quadratic inequalities in two variables. So now instead of just one variable, instead of x squared plus 6 is less than 5, now we have y is less than 6x squared plus 7, something like that. Okay, to solve a quadratic inequality in two variables, we have to determine the solution region. The solution region may be above the parabola and it may be below. In addition, it may or may not include the points on the parabola. Therefore, there's 8 different scenarios. Okay? So in this scenario, we have a parabola up. We have y is less than ax squared plus bx plus c. So I'm looking for everything below it. Notice I have a dotted line. The reason for that dotted line is because it's less than, not equals to. And this just tells me it's parabola up. Same thing here. I have y is less than, so I want the region below, but I have a parabola down. Okay? Next one, I have y is less than or equal to. So same thing, only now a solid line. I'm talking about the region below. And again, a solid line because it's less than or equal to, and this time parabola down. Over here, I'm saying y is greater than, so I'm talking about the region above. Dotted line because it's not included. And here is parabola down, dotted line, region above is what that tells us. And then finally, solid. Okay, once you have determined the solution region and shaded it, you have to select a test point. So if this is the region, I could select this test point or that test point, any test point within here, and I'm going to test it back into my original inequality to make sure that it's true. Just make sure you don't select a point on the boundary. Okay, let's try one. So y is less than 2x squared plus 5x minus 3. Choose a point in the solution region to check the original. So I went to Desmos and I did a graph here. So I want everything that's less than this. So first of all, this should really be a dotted line because I'm not including the boundary. And I want everything that is less than this. So the way I do less than is I talk about all the region below it. So I'm talking about all this region here. Y, all y less than that. So if I could shade in, I would shade that in all the way. Okay, anything below it here. So now the second part of the question asks me to do a test point. So I have to pick a point within here and sub it in. And I'm going to show you an easy way to pick a test point so our lives become a little easier. Okay, I think you get the point that I know how to color. So a test point that I'm going to choose is I'm going to choose this point right here, 0 and negative 6. The reason I chose that is watch this. When I sub it back into the original, my y value is negative 6 is less than 2 times 0 squared. Look, I already don't have to do much work. 5 times 0 minus 3. So is negative 6 less than this is 0, this is 0, negative 3? Yep, it is. Done. Okay. Next question. Graph y is less than negative x squared minus 6x plus 9. Choose a test point. So this time I have a parabola down, and I'm saying y is less than or equal to this. So first of all, it's solid. So I'm going to color it in solidly. And then I'm saying it's everything below this quadratic. So if I were to shade it in, I'm talking about the region below here. Okay, next it asks me to do a test point. And once again, I'm going to choose a test point pretty intelligently, hopefully. Okay, so I'm going to choose a point where my x is 0. So let's do 0 and negative 5. And I'm going to double check that this satisfies my inequality right here. So negative 5 is less than or equal to negative 0 squared minus 6 times 0 plus 9. Negative 5 is less than or equal to positive 9. That's true. So let's say I made a mistake and I accidentally colored wrong and I had shaded in the region above here. Let's say I made a mistake. Well, my test point would help me out. My test point would show I'd made an error. So doing this test point is really going to show me. So let's say I accidentally did the green. I chose this point 0 and 15. Okay, let's test if that satisfies my point. 0 is less than or equal to, 15, whoa, that's not what I wanted. 15 is less than or equal to negative 0 squared minus 6x plus 9. 15 is less than or equal to 0. That was 6 times 0, 0 plus 9. Is 15 less than or equal to 9? No. So that would show that I'd done something wrong. So my test point can let me know if I've done something correct or not. Okay, next one, write an inequality to describe the following graph. First of all, notice it's concave down. So it's going to be y, and then there's going to be a negative in front of the x squared of some sort. Also notice that it is the region above, so it's going to be greater than. And the other thing we'll notice is that it is a dotted line. So there's going to be no equal to. So it's going to be y greater than something. And what we're going to use is we're going to use vertex forms. Remember, equals y equals x minus p squared plus q, where p and q were the vertex. And looking at our graph, I can see that the vertex comes when x equals 3 and y equals 2. So the vertex is 3, 2. So I'm going to sub those points in. Y equals a x minus 3 squared plus 2. So now we need to figure out a. I know a is negative, but is it negative 3? Is it negative 7? What I'm going to use is another point on the graph. And this looks like a good point here. I could use that point too. Actually, let's use this one. So that's 1 and 0. So when x equals 1, y equals 0. I'm going to sub that in, and it's going to spit out a for me. So 0 equals a. 1 minus 3 squared plus 2. 0 is equal to a. Negative 2 squared plus 2. 0 is equal to a times 4, 4a plus 2. So I have 4a is equal to negative 2. A is equal to negative 1/2, dividing both sides by 4. Okay? So a is equal to 1/2. So putting that all together, I could say that y is greater than, we got that from here, negative 1/2, got that, just figured out what a was. Then I have x minus 3 squared plus 2. So that would be the graph of this inequality. And if I wasn't sure of that, if I was unsure, I could actually go into Desmos and graph that. Y is greater than negative 1/2. See if I can graph that or not. Y is greater than negative 1/2. X squared, x, what was it? Bracket x minus 3. All squared plus 2. And I should get the same graph that I got there. Let's see, it goes through 0 and 5, and that looks like the same graph that we had. 0 and 5. Yeah, looks exactly the same. Okay, so that's a way that you can check that. It's just, Desmos is neat because you can actually type in greater than, and if I wanted it to be greater than or equal to, I think, yeah, they're just down here, greater than or equal to. Okay, so you have a couple questions to try on this concept, and you have 2 days for this section.